Hey all, it's Piotr Gankiewicz, and this is the first part in which I'd like to guide you through the .NET Core application deployment. The purpose of this series is to actually show you that the so-called DevOps deployment, continuous integration, is not as complicated as it may seem at the first glance. So let's get started. I have these slides here. You can open this deck because it's publicly available. And during this series, we'll be just going through the very simple application that we have created with a friend of mine. And step by step, we'll be adding the new services in order to have this fully automated deployment system. Okay, so I named this presentation .NET Core from zero to deployment. I just translated it from my native Polish language to the English one. So let's get started with the slides. Little bit about me, you can find my blog here. You can find me on Twitter, also on GitHub. I really love the open source, so there's a lot of code on my GitHub, as well as our organizational GitHub. We are doing some open source projects, for example, like Be Collectively, and everything is actually written in .NET Core as well. And we are also using the techniques here that I will present you in this video related to the automated deployment, orchestration, and so on. So this is not something that is just my idea and have never been deployed anywhere. It's just something that is proven to be working and also used by many people around the world. All right, let's get started with our actual series and let's learn something new. So the prerequisites. Let's say you have the .NET Core application, and it doesn't matter whether it's a monolith, it's a SOA, it's micro or nano services, because I've heard that micro are passé now, it's nano services now. And you have the server, so a place where you can host your application, just a virtual machine, let's say, running somewhere in the cloud or at your basement even, doesn't matter. And you have a goodwill, you want to learn something new, and you don't want to running scared when you heard term deployment or DevOps or something like this. So we'll be using the .NET Core here, and I hope that you are familiar with .NET Core. But the idea is that all of the techniques that I'm about to show you are pretty much technology agnostic, which means that if you have a friend working with Java, PHP, Python, or anything else, he can actually do the same and achieve the same goal. We'll be just using .NET Core just to have the some application that is actually running on our system, and I'll show you how to deploy with .NET Core, but this is just the first part, and all of the other parts are really independent of the technology or the application that was used to build this app. All right, so what's the action plan? Here are 5 points. We'll start with Dockerization, so Docker, containers, all this stuff. Then with the automation and deployment, so we'll do these 3 parts in this first series, and then in the second part we'll go through orchestration and maybe some extensions. So going with this Latin sentence, we'll start as this small unicorn who wants to achieve some greatness. So pera, not that, sorry, ad astra, right? We want to have this great unicorn, a great system that is you just commit your code to the Git repository, and then the magic happens. There is the build, testing, creating and pushing Docker images, then deploying to the cloud, then scaling and all that stuff. And I'll show you that it's really not as complicated as it may sound. Okay, so let's start with the Dockerization part. So we'll focus there. Well, at first we'll run the app in a classic way. Then I will show you how you can actually put your app into the Docker image and how you can run it through the containers, how we can make use of the Docker Compose, and later on we'll publish our image to the Docker Hub so that we'll have a way to pull it somewhere, let's say in our hosting environment, and then run it, right? Because we'll need to store our Docker image somewhere, just like we store our code, for example, in a GitHub. And here we'll be, as an example, we'll make use of this Fibon app. So the Fibon is an app which we created with a friend of mine, Łukasz Pyzik, during our .NET Core tour. And If you haven't heard about this, I guess you didn't, because because it was like a local event. So both of us, we organized this .NET Core tour here in Poland as a series of free, like open and free lectures as well as workshops. We traveled through 20 different cities in Poland during like 2 or 3 months. It was a lot of fun meeting a lot of people, and we've been basically talking about the .NET Core. We showed this application as an example, what you can do with .NET Core and how you can deploy it, scale it, and so on. So these are just some arbitrary photos from events. Okay, let's get back to our project. So you can basically clone this repository, but you could also as well just create a new .NET app through the .NET CLI and also follow this tutorial. It doesn't really matter. We have here a little more advanced scenario, I would say. So let's actually take a look what our application does. I'm using Visual Studio Code, and I will run it in a classic way. Okay, let's start the app, and I'll just type .NET Run to start my API, and the .NET Run with this -- URLs, because I don't want to be these two apps in a conflict in terms of the port that will be used. All right, so I have my API, I have my service here. What I can do now is basically open my browser, navigate under this localhost 5000, and I can see there is my API, and here is my service. Okay, so what the app does is that if I type this /Fibonacci / for example 10, I should be able to get the value of the Fibonacci sequence for the number 10. And how can I do it? Well, basically I can run the CARE request like this, and this CARE request will go through my API. So right now I can see that there is my value for the 10. And basically it goes through the API, through the controller, Fibonacci controller, then it pushes it to the service bus, the RabbitMQ the scenario for this bus client. As you can see here in my post method, it publishes it. Then there is my service, it has a handler, it consumes this, calculates the value for this number, and then publishes an event like value calculated, which is then consumed by my API in this handler and stored in the repository in the memory. And here under my Fibonacci get method, I'm actually able to grab my Fibonacci number. So a very simple distributed application based on like 3 components, actually 2. We have the API, we have the service, which are both web API projects. We have the messages, which is a common contract. These are the messages that are being sent to the bus. And we have a RabbitMQ as our service bus. Okay, so the app is running, and as you can see, it runs fine. And we could actually take our code, run the .NET publish command, and then just grab our files and publish it to the server. And it will of course work. And this is how you could actually do it in probably one of the most easiest way. However, if you think about all of the complications, let's say there is an update needed for the app. What do? Do you stop your service, then replace the files, or maybe you have some staging server where you would include the load balancer and it would switch through one service to another while there is a deployment or the update on its way, and all these scenarios, right? So the purpose of this tutorial is actually show you how you can make these tools like Docker, build servers, and other stuff to publish your, to deploy your applications in a very, very automated way, and also very simple. Okay, so at first let's start with the Docker. What can I do here? Here I have the 2 files, actually 3. So I created this Docker file here in my API and also my service. So here I'm just saying, I want to make use of my .NET Core runtime. And where does it come from? Well, basically it comes from the Docker Hub. So if you would open the hub docker.com, and if you type here Microsoft, let's say, or Redis, or whatever, or anything else, you can see there is this .NET image. And I want to make use of this .NET Core runtime. So I want to have this minimal image that is capable of running my .NET Core apps as my actually base image. Then I'm just saying I want to make use of this .NET App work directory. I just want to keep my .NET Core application and files in this .NET App. Then I want to copy files that will be publish through the .NET publish command from my bin docker directory to my current directory, which is .NET app. And from as far as I know, this .NET app is suggested by Microsoft in one of its documentation. It should also probably work with other directory names, but I'll just stick to this one. And then I'm saying, well, I want to set up my environment to the Docker, but it doesn't matter. It can be production, testing, or whatever, or anything else. What it does, basically, based on this environment type, it will load the proper app settings. So if I was to set here development, then I could tag this Docker image maybe with the dev of development name, and it would just make use of these development app settings here, right? It would load them as their default ones. Okay, and here I'm just saying that entry point, so this is the command that will start my application in my container. I just want to make use of this .NET and pass my DLL. So this is how you run your published DLLs, not by .NET run, which actually starts the CS proc. You want to make use of .NET and then DLL name. And here I'm specifying my URLs, but I could also do it through the ASP.NET Core URLs. And I could also basically skip this part and just make it like this. And it would do the same through the environment variable, so it's also up to you how do you want to do it, okay? We can actually, let's make it maybe this way even. So like this for our Docker, and the same for our services. So here, I could also make use of this URLs and then 50/50. All right, so now how I can actually run it through the Docker? All right, let's just kill my RabbitMQ, which also runs through the Docker. So I will just stop it. As you can see, I can type docker stop and grab this container ID. So it's down now. Okay, and in my API, I just want to type docker build. And I just want to have a tag, like a name for my image. So I just type Fibon API, and then I type the dot as my directory in which the Docker file resides. So it built my Fibon API, and I can do the same for my service. So I'll just say I want to build a Fibon service dot. Okay, and that's it. We have the API, we have the Fibon service, and we could actually run it now, also through the Docker. So I'll just type docker run, and I'm just saying I want to open the port. So here I have this public to private port mapping. So if I would like to run this, for example, on port 80, I would say I want to have this exposed on a public port 80, and here I'm passing the private port that is exposed by my container. So the 50/50 for my service and 5000 for my API. So let's keep it like this. And then my image name, so the Fibon API, okay? And as you can see, it just started. I could open my browser and do the same. And I could also start my service this way. So if I type docker run, and then 50/50 to 50/50 port mapping, and then my Fibon service. Yeah, it was like this, I guess. It will start my Fibon service here, and everything is fine, okay? But what's the issue here? Well, the problem is that since these files live in their own containers that are separate from the world, we need a way to actually communicate between them. And of course, Docker allows you, like Docker has this support for the network, so your containers can talk to each other through this network by exposing ports and so on, and Docker network takes care of this. But let's say we have the RabbitMQ, or maybe some database or anything else that also is being run through Docker, especially for the development purposes. And then how you can actually make it work without starting all of your services in a different terminals and then setting up the network and so on. So let's make it smarter way. And at first, let me stop all of my Docker images so I can do it through this simple command, which will take all of the running containers and just stop them. So I don't have to stop them one by one by passing their IDs. Okay. So let's take a look at something that is called the Docker Compose. Here I have two Docker Compose files, but let's make use of the default one. And I'm saying the following. We'll get back to this one in a minute. Let's start with my services. I'm using the version 2. There is already a version 3 available, so it's up to you. I'll just stick to the version number 2 because it works for this simple scenario. I don't need any special comments available since version 3.0. So here I'm saying that I have this service. I named it, let's say, Fibon API. It's just some arbitrary name. You can put there anything you want. Just keep in mind that it's a YAML file and you need to beware of the indentation. And I'm saying I want to use the image Fibon API. And I just want to link it to the RabbitMQ. And here I'm using the RabbitMQ image that comes from the Docker Hub. And I'm exposing my port 5000. And here I'm also creating the Fibon service using the Fibon service image, which is on my local machine. And I'm actually also linking it to the RabbitMQ. So what's next? Okay. How can I actually start it through the Docker Compose? If I would like to actually build my images, not make use of existing ones, I could say here build and then pass the path to my image. So I would say fibon.api and it would go to this directory and it would build the new image based on a Docker file found here. If I would like to build the image specifically for my, let's say, development Docker file, which actually has the same data as my Docker file here, but with different environment name, I could specify the full path like this. But if I want to make use of the existing image, I can do it like this. And one more thing, before we actually build our images, before you actually build anything, you need to publish your application. So you have to run the .NET publish command like this, and then let's say publish with the release configuration. And as an output, I'm publishing also to this Docker. So these files will be actually copied in my Docker file from this bin Docker release directory. And then based on these files, I will actually build my image. So this is the first step that you need to do before building the Docker image. So you run .NET publish, then you run Docker build, and then you can run Docker run for your applications. Okay, so what is next? We have the Fibon API here, and we have our Docker Compose. So what I can do is actually I can get to my scripts folder, and I can run it through my Docker Compose. So the Docker Compose will take all of this and will run it through a single command. And like I said, we have this one more service here. I call it start dependencies because the thing is that I want to make sure that my RabbitMQ starts first before my services will connect, right? Because if it's not available here, then the connection may fail and my API will not work. So for this simple script, I am actually able to ensure that the RabbitMQ will start first. So in order to make this ordering the proper ordering, I have to type at first Docker Compose and then run, and then pass my script name or my service name. So let's do it like this. Okay, one more time. Let me save it. Let's clear it. Let's try one more time. All right. I have to, yeah. It's supposed to be an image, not a build. So let's run my start dependencies. And now, once it is completed, I can do the proper command. So I just type docker compose up, and this one will actually start all of these images. So this is how you start the application through the Docker Compose. Okay, so everything seems to be working here, as you can see in my logs. So let's try to run it again. So if I open my app here, it's not ready. So I can try to execute my care request. All right, great. My app is working and it's being managed by the Docker. It runs through the Docker Compose. So we are already one step further. Great. Let's stop all of our images. And now let's think about the next steps. So right now we know how we can actually put our app into the Docker container and how we can run it through the Docker Compose. The question is how we can actually push it to the Docker Hub. So as you can see, you can actually open the Docker Hub here. And here you can actually host your images. So you can host the public images or the private ones. And in order to do it, you just click on this create repository. You type the name of your image, whatever you want, and just click create. And you have a new repository to which you can push your images. You can also create an automated build. So then if you do it, and let's say you want to use existing image from an existing repository, you can actually just select the repository and it will build an image whenever there is a new commit to the repository. However, from my experience, it's actually much faster to build the images, for example, for the build server and then push it to the Docker Hub. It's just much faster way, because I realized that Docker Hub takes like more time to actually build your images. Okay, so I have here this API. I have my service as well. So let's actually try to tag and actually push our images to the Docker Hub. You can also make use, for example, of the Azure Container Registry, container service. So you can make use of this tool to actually keep your images on Azure or AWS, or you can even just get and build and start your own Docker Hub, because it's an open source tool that you can run on your, let's say, private virtual machine in your network in order to keep your images. But everything works the same. Okay, so once you create an account, let's say on Docker Hub, and you create a repository, what you can do is to actually log in. So if I just type docker login, and if I wanted to, let's say, log in into the Azure, and I would have for example, this endpoint, I would do like this. But if I want to just log into my Docker Hub, I just type it like this. So it has my username, there is my password, and I should be successfully logged in right now. So if I type Docker images, you can see that I have quite a few images here, and I just want to push these images. Okay, I want to push them to the Docker Hub. So the first thing I want to do is actually I want to tag them. I have to tag them so that I'm able to push them to my Docker Hub like this. So I'll just type docker tag, then my local image name, the Fibon API, and then my remote name. So the full name, so the spec / and the repository Fibon-API. As you can see, I don't need to have the same naming here. So whether it's dot or dash or just even a different name, it doesn't really matter. So I want to do it like this, and then I just want to tag my Fibon service. And now I can just push it, docker push. And this one will actually take my image and it will push it to my repository. Okay, so after this push command, my image will be actually updated in my Docker Hub registry. So let's cancel it, as I already have the images here, and I have actually two images. Let's say the production ready and the one for the development that I updated a few hours ago. So we are already here. Okay, you know how to keep your images in Docker Hub. Now let's find out how to actually deploy it. Okay, and before we deploy it, let's think about how we can actually make this deployment more automated. So how we can actually make a commit to your repository, and then some build server will just run and build your stuff. Okay, in my Visual Studio Code, I added a few scripts here for this Fibon repository. So let's take a look. I'll be using here as my build service the Travis CI, which is free for open source projects. So in order to get started, just log in through the GitHub. and you just you sync your account with your GitHub, and you just select the repository that you want to build. As you can see, I have this Fibon, and now I can just open my Fibon, and I can go to the important part. I just go to my settings here, and here I just want to create 2 custom environment variables for my Docker password and username, so that I'll be able to actually build a Docker image and then push it to my Docker Hub. All right, and you can also make use of other build services. For example, I'm also have this sample here for the Bitbucket pipelines, which is also pretty cool. And the same scenario here, I have my settings there, and I have my environment variables, and also the Docker password and the Docker registry. Here I'm even using the Docker registry that comes from the Azure as a different sample, and just my username, my password, and the registry name. Okay. So once you have these environment variables in place, let's take a look how we can actually integrate with our build service. So for the Travis and for the Bitbucket, it's very similar. I just took this one for the documentation. Here I just want to make use of the C# .NET Core 2.0. I only want to build the master and develop branch. I don't want to build any other branch. Here I just want to set, before I run anything, I just want to have these proper execution rights for my scripts directory. And here I'm just running through different scripts as the next steps. You could basically put there your bash commands. You don't need to put them into the scripts, but for me it's just a better approach, at least for me personally, because I have different steps in a different build scripts. So let's go step by step. We have at first our .NET build, which is pretty simple. So .NET build just calls the restore and build. We could even just call the build because it will do the restore under the hood since .NET Core 2.0. The next step is the .NET test. So .NET test will just run the test on our test project. So once our test pass, I just call this .NET publish. So .NET publish will actually, as I shown you before, it will call this .NET publish command, and it will make use of this release configuration and publish our files to this bin Docker. And then what else? We have the Docker publish Travis. So this one is actually more complicated. So as you can see, I have 2 things. I have my Docker environment and my tag as the variables. And if it's a build coming from the master bench, I just set my environment to the production, which means that for building my Docker image, it will make use of the Docker file, that production file. Okay, let's get back to my Docker publish. And for the development, it will make use of the develop. And for the master, I make use of the latest, which is a pretty common, like the latest is usually the tag that you use for building the latest, for saying that this Docker image is like the latest, the production ready, and development with the dev tag. So here I'm logging to my Docker Hub for this using the environment variables. So I'm providing my username and my password. And once I'm logging in, I'm just calling this Docker build, and I'm specifying here the full path to my Docker files. So based on my branch, it's either production or the development. And here I'm just tagging my my files, my Docker images with the proper tag, which also comes from this from a different branch. Okay, and that's pretty much it. So I'm building my API in service. Here I'm tagging it the same way like I did on my local machine. And once it's completed, I'm just pushing it to my repository, to my Docker Hub repository. So the thing is that when I actually commit the code to my repository, then the Travis CI service will start. It will just execute. It will start building my images, as you can see here. Let's open the log. Here is the Travis build. Yeah, it executes the .NET build. So it builds. Then below, there are tests. Okay, the tests passed. Then there is this .NET publish, Docker build, and finally it pushes the images, Docker images to the Docker Hub. And here I have this after success script, and it just says hooray. And this one is also defined here after success. And the same one is actually for my pipelines. So for the pipelines, you have this bitbucket-pipelines file. and it's pretty similar. You're just saying here which type of image you want to use, and then you specify what should happen for each branch. Like for the master branch, I want to just set this Docker environment variable. I want to have this proper execution rights for my scripts and the same steps. The only difference is this Docker publish. So I have different one for the Travis and different one for the publish, which is also similar for my Travis. But I'm just also using this Docker registry as I'm publishing my image to the Azure for the scenario with the Bitbucket pipelines. Okay, so this is how the build services may look like. And what will happen now if I push the commit, if I just commit the code and if I push it to the repository, then all this stuff will start building. So whether it's my GitHub or whether it's my Bitbucket repository, so either the pipelines or the GitHub will start executing. And once they complete, they will just push my brand new Docker image to my Docker Hub, and I'll be able to actually deploy it. So it was this step, and now the last step for this series, for this episode, how to deploy it. I have a brand new virtual machine running in the cloud, so I'll just log into it. And what I want to achieve is to actually open this URL and have my API up and running, okay, along with the service and the RabbitMQ. So let's go step by step. I have the Ubuntu server here, and at first I will just type apt update, so it will update update the system packages. Now let's actually install the Docker. So I'll just type apt install docker.io. Yes. Let's wait a second. It's really pretty fast. And after that, I wanna install my Docker Compose. I'll just type apt install Docker Compose. Yes. Okay, and everything will be there. Now the question is, how can I actually make use of these images here? Well, let's see. Let's clear it and let's create a new file. I'll just name it docker compose.yaml. And I will just make use of this docker compose YAML, but I will just change my image name to the image that comes from my Docker Hub. Okay, so like this, and here like this. All right, the rest remains the same, and I'll just copy it, and I'll put it here, save my file, and let's actually run it. So at first, docker compose run, start dependencies. And at the beginning, we'll have to wait because for the first time, it will have to pull all of the images. So it will pull the RabbitMQ image for the first time, and it will also pull the .NET Core image and our Docker Hub images as well. So for the first time, it takes a little bit time, but it's pretty fast, as you can see. And now let's run. So docker compose up. It will pull my images from my Docker Hub specified here. So it will just grab this image with the tag latest from my Docker Hub. So it will take this Fibon API and the Fibon service image in order to run it. So just hold on with me and we should have our API up and running there. All right, great. So what I should be able to do now is to actually open my URL like this. All right, seems that it works. Let's see. And now let's try to actually execute the curl request. So once again, I will just type curl and the port 5000, and I want to do post request with an empty data. Okay. Oh, I need to specify the URL to my Fibonacci. So the Fibonacci /5 endpoint. Seems that it went through. Fibonacci 5. Well, that's great. It works, right? As you can see. So it seems that we've just successfully deployed our application to the virtual machine running in this scenario somewhere in the cloud, in the DigitalOcean's cloud, or maybe in on your own private environment, or even your PC in the basement, doesn't matter. And one more thing that we want to do, so let's just kill our services here And let's install the Nginx, and I will tell you why. So I'll just type apt install Nginx, and Nginx is very powerful and also the open and free to use HTTP server. Okay, so let's just run this Docker Compose again. So this command, and then I'll run the Docker Compose up, but in that scenario with the -d flag, so it will run in the background. So let's see, our images are here. Okay, everything is running. And if I open my URL here, I will see this welcome to Nginx. And what I wanted to do now, and why I want to do this, well, even though we are able to run our application through the Kestrel, which is basically this server for running our .NET Core apps, still, it's not the proper choice for the production deployment, because as great as Kestrel is and as fast as it is, if you think about just some fundamentals like plugging in the certificates, so you have the trusted connection, the SSL, TLS, or load balancing or other stuff like that, this is something that Kestrel can't really do on its own. You need to have some other server like the IIS, Apache, or Nginx in that scenario that will actually open the port to your application. Like, let's say we'll hit this website, and this will be the Nginx server, and it will redirect your move to your application running somewhere in the local port, and it will take care of things like SSL, TLS, load balancing, and all that stuff. Okay, you want to have some, you want to have this designed server, HTTP server, that will take care of all of these things, and it's very easy to actually do. So let's navigate to the etc nginx sites enabled directory, and I will just remove the default config. So just type rm default, and let's create a new default configuration. So nano default, and here I will just paste this nginx config, and you can find this config at the official ASP.NET Core Linux integration docs. So I'll just copy it here. And what it does, well, it says I want to listen on the public port 80, and here I want to make use of this proxy pass, which is basically this mechanism called reverse proxy. So whenever there is something going on at this port 80, I want to redirect all this movement and pass it further to my app running at localhost 5000. And here I'm just setting a few headers that are required by ASP.NET Core in that scenario. So I will just save this file, and I'll restart my Nginx. And let's see what happens now. Voila! It seems that everything is up and running, and Nginx redirects our movement to the API. We could also expose our service or maybe keep it internal. We could add here some certificates, some load balancing, and all the other good stuff. But where are we at now? We are at this deployment, and we've just finished this part. So we set up our virtual machine, we logged into it, we configured our Ubuntu server by installing the Docker Compose, the Nginx, and we finally configured our Nginx so it redirects all of the traffic through this reverse proxy mechanism, and basically our app is working as expected. And this is all for this first part. And in the next part, you will see how we can actually add this, maybe not one, but add these missing steps. And what I mean, well, even though we have this automated build set up, so we are able to just push the code to the repository, and then it will, the Travis CI or Bitbucket pipelines or any other build service of your choice will build it, test it, then build Docker images, then it will push the Docker images to your Docker Hub or Azure Container Registry or anything else. But we are still missing this part that will actually take these images, also, for example, by calling some webhook, and then deploy it. And then we also need some tool that will be actually able to replace our images and then scale it, upgrade it, and also include some other things like load balancing and so on. And this is the tool that we'll talk about in the next episode. It's called Rancher, and it's a really great tool for actually managing your platform, whether it's a simple app that you can host in a single container, or whether it's a distributed system that requires tens or even hundreds of different services that should be run on a multiple virtual machines, this is something that Rancher can take care of. And in the next episode, you will see how to make use of it and how we can actually deploy our Fibon application with the Rancher. So thank you for watching. I hope that it was I hope that you learned something new in this video, and just let's wait for the next part in which I'll explain the additional steps so that you will become like you will become a professional DevOps on top of being a great C# developer. So take care and see you next time.